and control plane demos. Today we are going to be talking about network operations, monitoring, analytics, and dashboards. So one of the most important things from a uh, networking point of view is that how you can actually do operations and how you can do monitoring and what does it mean to do analytics and dashboards. Today, people buy complex, apart from buying switches and other networking equipment, they also have to buy complex operations software and be able to configure it and then monitor it and manage it and all the other things. So Faucet SDN controller provides you with inbuilt network operations monitoring. We do it through, there are two things that we need to worry about when we are trying to manage an OpenFlow switch. One is the OF stats, basically that is the OpenFlow stats that are provided by the OpenFlow switches as a part of the OpenFlow specifications, which are actually sent to a InfluxDB, which is a real-time database, and through that we are using that as a data source for Grafana, which is an open source network monitoring charting tool that is there so that we can actually do custom dashboards and everything. There is also another aspect of an OpenFlow switch that one needs to monitor and make it available to other applications, and that is basically the flows on the switch. Instead of directly interrogating the switch at all points in time and reduce the performance, if a database is actually integrated in an intelligent way to the switch, then applications can actually interrogate the flows on the database, and for a database which is actually programmed or written so that it can actually handle large amounts of read transactions without really impacting the performance of anything. And in order to do that, I just want to bring your attention to the Faucet architecture itself. Okay, so as we have been talking about in the previous demos, the Faucet is basically an application running on a Root controller. Basically, that is what we call as a Faucet controller. And we actually update the faucet.yaml file in order to manage all of these switches. So we have also talked about the fact that one faucet can actually manage multiple switches. Now, Faucet is an in-memory controller, okay, so that it does not really depend upon any disk or anything like that. And we can actually have multiple instances of that for high availability and scalability. But we were talking about databases, which is purely a disk-based operation. What we don't want to have happen is if the database fills up and you're out of space, you don't want the machine to crash or anything like that. And that would be disastrous for an SDN controller, which always needs to keep in contact with the switch for operations. So that is why we have split this so-called brain, wherein the brain itself is the faucet, which is constantly talking to the OpenFlow switch and maintaining communications. And we have another controller called Gauge, which is basically more or less the same code, but it has all kinds of bells and whistles, so as to say. It has the ability to talk to a NoSQL database like CouchDB for all the flow information, and or it can talk to any kind of Python database, okay, SQL database too, as long as it is configured and we have there is a code for that. And it also takes all the stats from the controller and from the switch, sorry, and then put it into a time series database called InfluxDB, which is exported via Grafana. So this is how the architecture is. So even if Gauge is not working, all that you are seeing is that there is no stat information that is being pulled from the switch, and then there is no flow information that is being pulled from the switch. It is not a disaster. It is basically there. All applications now can connect to this Gauge controller, which basically means that you are connecting to either CouchDB or InfluxDB and constantly and keep pulling data. So that is what most of them really want to do anyhow. If you want to add flows or anything like that, you would want to come through Faucet, but that's a totally different ball game altogether. You don't want to add arbitrary flows anyhow into your system, because that would basically means that you would compromise it. We will talk much more about how to deploy it, best practices in a different at a different time. But for now, I think that is more than enough. All applications can talk to Gauge to get data switch information, flows that are installed on the switches and that kind of stuff. If you use the simple cap theorem principles, which is basically uh, this database will make sure that it's available, and it is near consistent information, because we poll the switch every 10 seconds to get the stat information, and every 1 minute to get the flow information. So that is how it's actually done. So just to give you an idea, this we had deployed Faucet SDN controller at the ONF, which is Open Networking Foundation member workday, where we had around 200 plus people who come in, and they basically utilize the network. We had provided the OpenFlow Wi-Fi. What you can really see is that it starts at around 9 o'clock or 10 o'clock. That is when the network starts picking up, and you can see that the bytes out. It is going all the way up to around 5 o'clock, and then it plateaus. Okay, this is overnight because there is no real network traffic. Again, you can see from the next day at around 9 o'clock it starts going up. We handled around 8 gigs of traffic. Okay, so now let us take a look at the faucet.yaml file for a minute. Okay, so I'm going to do faucet.yaml. Okay, so we have lots of things here, but we don't have something called mirror. Okay, so I am going to okay. So what I'm actually going to do is that I have a faucet. I have a faucet.yaml file, which basically has an ACL called 101. And basically what it does is any port which applies this ACL, okay, it will take that traffic and mirror it to port 11. That is what we are really showing. Okay. With that, let us see as to where we have applied this. We have applied this ACL on port 7. That means any traffic that comes on port 7, it will be mirrored onto port 11. Okay. So with that said, okay, let us copy faucet demo step 3 .yaml as faucet.yaml, and I'm going to restart the controller because this policy needs to be applied. Okay, I just applied this. Okay, screen minus. So controller is running. Get our screen. Okay, now I'm going to take you to the dashboard that we have. So this is basically all the port mirroring traffic that we are showing. Okay, and this is the internet traffic, so which we have deployed it on this network. Okay, we are actually monitoring the OpenFlow Wi-Fi network. Okay, and all the ports that are associated with this, and then you can actually see packets that are coming out, and you can do all kinds of intelligent stuff out here. Okay, you can do bytes in mean, and you can do packets out, and you can do all kinds of things, and you can do gauges, you can do pie charts, all of those things. And I mean, it basically, you can completely customize this dashboard to your heart's content on what exactly you want to see out of this. And we provide you with numerous facilities in order to make all of these things happen. We are adding more and more functionality to do all kinds of fine-grained stuff. But we want to do, like, for example, I want to see all the HTTP traffic, or I want to see all the DNS traffic. You can basically see segregate all of that stuff and do fine-grained SDN controller. And as we have talked about in the previous demos, this thing gets installed in less than 30 seconds. Faucet can be installed in 30 seconds, and within half an hour you can deploy a very complex network, which provides you with all kinds of network management facilities and everything. And here are some resources for you to follow up on. And thank you for listening.